students, again I am back with another part of my video on the chapter carbon and its compounds. Okay, so in my previous video I told you about the formation of some covalent compounds, how covalent compounds are formed. Okay, and since it was a long video, I told you that in my next video I will be talking about the covalent compounds, the characteristics of covalent compounds. Okay, so when we are talking about covalent bond, basically covalent bonds are definitely strong bonds and they are directional bonds. Okay, because what happens is that the electrons are placed at a particular place, they are there in the center. Okay, so they don't move here and there, so they are, because they are shared equally by the atoms which combine together, right? But thus the compounds which are formed, they are the covalent compounds. And if we look at the characteristics of the covalent compounds, the very first characteristic that we come across is the low melting and boiling points. Now covalent compounds, they have very low melting and boiling points because the bond, definitely as I told you, it is strong, but it is not as strong as the electrovalent bonds. Okay, so because in electrovalent bond there are two opposite charges and their attraction towards each other is much more than the attraction of the two atoms which share electrons. Okay, so that's why they have low melting and boiling points. Now the second thing is that they are non-conductors of electricity. So why they are non-conductors of electricity? It is obvious that they do not form ions. They don't have ions, and whenever we talk about electricity, we know that ions, they actually are the ones which carry the electricity, or the flow of ions is what basically makes electricity flow. So since there are no ions in covalent compounds, so they are non-conductors of electricity. Then the third point is that they are usually insoluble in water. Now usually water is a polar solvent, as I told you. Okay, so any compound which basically has polarities, or you might say that they have positive and negative ions, they will be soluble, but the covalent compounds, they don't have any positive or negative ions, they don't break, they don't have polarity as such. Okay, so usually lots of covalent compounds, they are insoluble in water, but yes, some polar covalent compounds are soluble in water. For example, when I say hydrogen chloride, okay, so hydrogen chloride, if you try to dissolve it in water, it will dissolve in water. Okay, it is soluble in water. That's why I have written usually insoluble in water, right? Then they are slow reactors because since there are no ions, there is no movement as such of the ions, because normally in electrovalent compounds, what happens when you dissolve it in water, it breaks into ions and then quickly the reaction happens. But in case of covalent compounds, their rate of reactions are little slow and you require some catalyst, okay, to change that rate of reaction to make them react faster. Then they show isomerism. Now this is a very new term that you all are listening to, or you are coming across. This term, actually you will be studying this isomerism in this particular chapter only later on. So usually what happens, the covalent compounds, they have a molecular formula and they may exist in different structures. So they can be different structures for one particular compound. Okay, so any compound you can take, it will have different structure. So that is what we call as isomerism. So isomerism is a property in which a compound has one molecular formula but different structural formula. So we will be talking about isomerism later in this chapter. Okay, so these are the characteristics of covalent compounds, right? Fine. And I think I told you about the polar covalent compounds in my previous video. I have cleared that, right? So now I am going to move ahead and I'm going to just erase this, and now I'll be talking about the allotropes of carbon. Now I'm going to take up carbon because the chapter is carbon and its compounds. Okay, so now I'm going to talk about some physical properties of carbon, and then we will move ahead and take on hydrocarbons, right? So I'm just erasing it as of now. Right. So now I'm going to talk about the allotropy. Okay. Now, allotropy. Now this is a very new term for you people, allotropy. Now you must have observed that many elements, they can exist in more than one, forms. Their physical forms may be very different. Okay. Now let us just take coal and diamond. Now if you compare both coal and diamond, definitely you will find n number of differences. Okay, you will be able to see and you will be able to make out, okay, this is coal, and once we get a polished diamond, of course it is diamond, right? Because they have marked differences. But you know that both of them are nothing but carbon. Both of them are carbon, right? If you take graphite, now the pencil lead has got graphite in it, right? So if you take graphite and if you compare it with carbon, with diamond or something, you will find again a lot of differences. Now this way, any element which exists in different physical forms, we call this property of that element as allotropy. Okay, so what is allotropy? Allotropy, the property by virtue of which the property by virtue of which any element exists in more than one physical form. Okay, which exists in more than one physical form, or it can exist in different physical forms. That is what we call as allotropy. And what are these physical forms known as? The physical forms, the different physical forms, of any element are known as allotropes. What are they known as? They are known as allotropes. Okay, so allotropes or allotropic forms, right? So this is allotropy and allotropes. Now I am going to talk about the allotropes of carbon or allotropic forms of carbon. Okay, so let us talk about the allotropic forms of carbon, since we are talking about allotropy. Right. Now let us talk about the allotropic forms of carbon. Allotropic forms of carbon. Okay, now if we look at carbon, carbon basically exists in three different allotropic forms. What are they? One is a crystalline form of carbon. One is crystalline form of carbon. Another is amorphous form, and third is Fuellery. Okay, now these are the three physical forms in which carbon exists. Okay, so when we are talking about the crystalline form of carbon, we have two examples of crystalline form of carbon. We have diamond and we have graphite. okay, which is very common, crystalline forms of carbon, diamond and graphite, right? Then we have the amorphous form of carbon. Now, when we are talking about the amorphous form of carbon, we have carbon black, charcoal. First is carbon black, then we have charcoal, okay. Then we have this yes, carbon black is the soot that we get, okay. Then we have charcoal, and then we have this coke, coal, okay, and all these things. So we have the coke, we have coal, right? So all these are different amorphous forms of carbon, okay. And then we have the fuellery. Now fuellery, basically it is there are lots of carbon atoms, many carbon atoms that are combined together, and they form a structure, some dome shaped structure, which we call as fuellery, okay. So this, for example, you can call it as C60 or something, where you have around 60 carbon atoms which are combined together. So fuelleries are very special type of this thing, forms, physical forms of carbon, which consist of a large number of carbon atoms joined together, okay. So this was the different allotropic forms of carbon. Now in your syllabus you have to study the crystalline form. You will be studying about there will be a comparative study on the crystalline form of carbon, right? So today's video I am just winding up over here. In my next video I will be talking about the crystalline form of carbon. I will be talking about diamond and graphite, and we will be doing a comparative study of both the different allotropic forms of carbon. Fine. So till then, goodbye, take care.